The term Earth system includes the interaction between the Earth's physical, chemical, and biological processes. The Earth system broadly consists of the solids, liquids, and gases that make up the Earth. We experience the Earth system as weather, climate, and natural hazards that are all controlled by the Earth system. Tornadoes, hurricanes, hailstorms, earthquakes, floods, droughts, volcanoes, extinctions, asteroid impacts, and mosquitoes are all part of the Earth system. Earth system science presents careers that combine research and education that investigate and describe the world around us. Past, present, and future are studied in a number of different ways. Earth system scientists work underwater, underground, in space, in the desert, and in the Arctic. The Earth system consists of four components: the atmosphere, a thin layer of air that surrounds the Earth; the hydrosphere, water, including oceans, lakes, rivers, groundwater, and ice; the biosphere, all living things. Solid Earth or lithosphere includes rocks, unconsolidated sediment, but primarily the solid Earth consists of three components: the core, mantle, and crust. In this course, you'll learn how these components interact with each other. Now, when we talk about topics such as global change, as they're related to Earth system science, a couple things stand out. Climate is changing now. Climate has changed in the past. Climate will change in the future. And we want to know how this will affect us. The Earth is currently being altered at an unprecedented rate by human activity. Greenhouse gases are warming the atmosphere. Chlorine compounds severely damaged the ozone layer. It's now recovering. Deforestation and agriculture have destroyed natural environments and decreased biodiversity. Key questions related to Earth system science. What is meant by a systems approach? How does global warming differ from the greenhouse effect or climate change? And is global warming actually occurring today? What is the Antarctic ozone hole and what is its significance? Should we be concerned about tropical deforestation? What can understanding Earth's past tell us about Earth's future? The Earth has changed constantly since the beginning of Earth time, about 4.6 billion years ago, or gigaannum as presented here. At the present time, things are changing at a rate that may be as high or higher than at any other time in Earth history. This is probably not true, as there were 5 mass extinction events that we are aware of in Earth history. The term anthropogenic is important here in that it implies human-induced. Literally, it means of human origin. And it describes things such as pollution, deforestation, extinction, domestication of plants and animals, also known as farming. Key questions for global change: what is meant by a systems approach? We'll view the Earth as a system of interrelated and interacting components. An example here is the biosphere interacting with the hydrosphere, atmosphere, and lithosphere. So we have tree roots that are working their way into the fractures in this rock and splitting the rock open. Now, the tree, as part of the biosphere, is obtaining nutrients and ultimately water from this rock. So it's engaged in the hydrosphere and lithosphere in that aspect. It's also taking in carbon dioxide and releasing oxygen while it's producing sugars and more complex molecules like cellulose and lignins. So we can see all of that happening here in this image. Now, key questions regarding global change include: how does global warming differ from the greenhouse effect? And is global warming occurring today? Global warming, by definition, is a warming of the Earth's atmosphere that is due to an anthropogenic enhancement of the greenhouse effect. That's very important to know this. A warming of the Earth's atmosphere that is due to an anthropogenic enhancement of the greenhouse effect. The greenhouse effect acts such that gases absorb outgoing infrared radiation, or radiant heat, heat that we can feel, and re-radiate it back to the Earth's surface. Is global warming happening today? Most likely. The greenhouse effect is a completely natural process, operates on all planets with atmospheres. Greenhouse gases are gases that warm a planet's surface by absorbing outgoing radiation and re-radiating it back towards the surface. That's depicted here with a model of a greenhouse. So we have the sun emitting energy at a fairly short high energy wavelength that passes through the transparent atmosphere. Now it's transparent to that high energy wavelength incoming radiation. It passes through the glass or plastic of a greenhouse. Ultimately, it's absorbed, and we'll say for our purposes, with 100% efficiency. Once it's absorbed here at the surface, it's re-emitted as outgoing radiation with a longer wavelength. This longer wavelength is trapped by the confines of the greenhouse, be it glass or plastic in this case. The most abundant anthropogenic greenhouse gas is carbon dioxide. The greenhouse effect is completely natural, again, operating on all planets with atmospheres. Important greenhouse gases on Earth include, but are not limited to, carbon dioxide, which enters the atmosphere from natural and anthropogenic sources. Methane, likewise, has both natural and anthropogenic sources. We can see these natural sources here, the termite mounds in the cathedrals of the north, in the Northern Territories of Australia. We can see it in the rice paddies of Southeast Asia. These are environments that were created by people starting about 5,000 years ago. So these emit large amounts of methane, as do the termites building these cathedrals of the north. And lastly, we have cattle as very important biogenerators of methane. These in particular are Highland cows from the Highlands of Scotland. Water vapor is perhaps the most important greenhouse gas of all, and it's one of the least talked about. Water vapor, being the most important greenhouse gas of all, is depicted here in a hurricane where air is rushing along the Earth's surface to replace the rising air that is lifted at the center of the hurricane. This results in a rotation in the northern hemisphere, counterclockwise rotation, as the air is rising from the center or eye of the hurricane. So air streams in from all directions to replace this rising air that's spiraling above the eye of the hurricane, or adjacent to the eye of the hurricane.